Hi, I'm Mary, and this is another Magical Math Moment. In this video, we're going to be looking at information regarding functions and their inverses. This is designed for Algebra 2 students and maybe some students in pre-cal or college algebra who haven't thought about this in a while. So we're starting off here with the steps for you. You can see here what we're going to do is if we have an f of x or a g of x, any of those letters, we're going to replace that with a y. Then we're going to switch x and y, solve for y, and finally replace y with f inverse of x. So this little symbol down here, this notation, f inverse of x. Some people say it f inverse x. I like of x. That's just me. That's the way I was taught, so that's what I do. All right, so here we go. The first step, replace f of x with y. So y is negative 7x plus 3. After that, I'm going to go ahead and switch x and y. So this is x equals negative 7y plus 3. From there, I'm going to go ahead and solve for y. That's this step. So we'll subtract a 3 on both sides. X minus 3 equals negative 7y. Divide by negative 7. You don't want to leave a negative in the bottom, so I'm going to change all of these signs. Negative x plus 3 over 7 equals y. Finally, at the end, we're going to replace y with f inverse of x. So negative x plus 3 over 7 equals f inverse of x. Some teachers might like you to put that over on the left side. It just depends on what your instructor's preference is. Additionally, some teachers might like you to split this up into negative 1/7 x plus 3/7. Again, equivalent expressions, teacher prerogative, I don't know. Okay, so that's how you find an inverse when you're dealing with a linear function. Let's see if we can figure out some other stuff. A function is invertible when it passes the horizontal line test or no y values repeat. When they're talking about the term invertible, they just mean that the inverse is also a function. So if I look at this first one, this is kind of like a cubic function. If I draw a bunch of like horizontal lines, they're only intersecting in one spot, so it passes the horizontal line test. This is a lot like the vertical line test for determining if a graph is a function or not. So in this case, yes, we could find an inverse. Over here, this looks like it's quadratic. If I go and draw my horizontal line, no, it's not gonna work, okay? Remember when you're doing this to look at the entire graph. So don't just go down here and say, oh, it's a tangent point, it works. No way, man, you gotta consider the entire function. So just be mindful of that as you are doing these problems. All right, sometimes they'll give you tables and they'll ask you if it's invertible from the table. So you're gonna examine the y values. Here I'm noticing that 2 and 2 repeat. So since the y values repeat, no, it's not invertible. No y values repeat in the second one, so yes, it is invertible. Isn't this fun? All right. If I have something like g of x is equal to the square root of x minus 5, I can find the inverse of that, all right? So we're gonna go ahead and, oh, what am I doing? I'm getting carried away with myself. I'm gonna replace g of x with y. Oh my goodness. Then I'm gonna switch out x and y. Now I can go ahead and square both sides. So I have x squared equals y minus 5. Remember that the square root being squared, their inverse operations are going to cancel out. Then we're going to add a 5 on both sides. X squared plus 5 equals y. And then your final step is to replace that y with f inverse of x. Ta-da! Wasn't that fun? I kind of like these. Okay. Next, we're going to look at a cube root. So again, we're going to go ahead and replace the h of x this time with y. And we have the cube root then of 2x minus 1 over 4. Next, I'm going to switch the x and y's in the equations. Then I want to get rid of this cube, so we're going to go ahead and cube both sides. So I have x cubed equals 2y minus 1 over 4 cubed, 64. Ooh, I almost got tricked. All right, I'm trying to get this y by itself, so I have to multiply by 64 on both sides. 64x cubed equals 2y minus 1. I'm trying to get this y by itself, so we have to add the 1 first. 64x cubed plus 1 equals 2y. And then we're going to divide everything by 2. So I get 32x cubed plus a half, or 0.5, is y. And the last thing we're going to do is replace that y with an f inverse of x. There we go. Okay, that wasn't so exciting, but it was all right. Okay. Are f of x equal to 3x minus 2 and g of x equal to 1/3 x plus 2/3 inverses of each other? All right, to figure this out, we can use function composition. For a function, for two functions like this to be given and for them to be inverses of each other, f of g of x has to equal x, and g of f of x also has to equal x. So we're going to do function composition. F of x is 3x minus 2, g of x is right here with 1/3 x plus 2/3. So first we're going to find f of g of x. All right, so the f function rule says 3 times something minus 2. The something, remember, is g of x. 1/3 x plus 2/3, and then we can just go ahead and do some algebra and math. Distribute the 3 in, 1/3 of 3 cancels, so I have an x. 2/3 times 3, the 3's cancel, I have a 2. X plus 2, and then minus 2 at the end gives you x. Yes, that's what we want. Let's see what g of f of x gives us. So the the g of x function rule says 1/3 times something plus 2/3. Okay, the something is f of x, 3x minus 2. All right, here we go. Distribute this in, 1/3 of 3 again is 1, so this just gives you an x. 2/3 minus 2/3, 1/3 minus 2 is negative 2/3, and then I have this positive 2/3. Oh look, they cancel. I get x again. So yes, f of x and g of x are inverses, and we can be happy about that. Let's look at one where that may not be the case. What if we look at f of x is 3x minus 2, and this time g of x is 1 over 3x minus 2. Obviously, we know from the last one that this is not going to be the inverse, but let's see if we can play around with it just to verify that it is not the inverse. So the f function rule says 3 times x, or 3 times something, minus 2. Wow, I wrote that really big. G of x is going to be the something we throw in here, 1 over 3x minus 2. Okay. Well, that's disgusting. Let's put it over 1 and just multiply. We're not really distributing anything in here. So 3 times 1 is 3. Down here, this is 3x minus 2, and that's minus 2. Yeah, there's no way this thing is going to give us x. So no, these are not inverses. So once you get to this point where either f of g of x is not x or g of f of x is not x, you can kind of stop and say, no, they're not inverses of each other. I hope that this video has helped you understand function inverses a little bit better. If you liked it, please go ahead and hit like, and feel free to share with your classmates. Subscribe so you can get more amazing algebra and pre-calculus content. Thank you so much for watching, and I'll see you next time. Bye.